Hi everyone. So let's start normal forms. Let's study what is this concept normal forms. So why we study normal forms that I will discuss later. Okay, in the next lecture I will discuss. So what is the reason we study this normal form? Like what is the motivation? What is the applications? So that we will study in the next lecture. But before that, we will just study this normal forms. All the type of normal forms we will study. And in the next lecture, we will see why we study normal forms. What is the application of normal forms? Okay. Now, so what we are going to do, a relation basically, a relation can be in many different forms. A relation, depending on the relation, that can be in these forms. Okay, for example, it can be in 3NF or it may not be in 3NF. It may be in 3NF, it may not be in 3NF. It may be in 2NF, it may not be in 2NF. Okay, something like that. So you can notice a relation, or I can say relation schema or relation scheme can be in the following normal forms: 1NF, 2NF, 3NF, 4NF. So let's start them. Okay, let's study what are these normal forms and how can we decide if a relation is in these normal forms. Is that clear? This is our target. Given a relation, is that relation is in which form? Given a relation, that relation is in 2NF, 3NF, BCNF. Okay, which form? So that we need to decide. Okay, let's start. So let's start with the first normal form. What is this? First normal form. This is very simple. Actually, every relation is in first normal form. In relational algebra, every relation is in first normal form. So what is this first normal form? This basically says that domain must be atomic. This is the statement. Domain must be atomic. Domain is atomic, means the elements are indivisible. Means you cannot divide the elements. Okay, is that clear? We have already seen this in the relational model. Like what is the meaning of domain is atomic? What that means? That means you cannot divide the elements of the domain. Yes or no? You cannot divide the elements of the domain. Is that clear? So you can notice this is the first normal form, that domain must be atomic. Domain must be atomic. Okay, so elements of the domain must not be divided, means elements of the domain must be considered as indivisible. You cannot divide any element of the domain. Every element of the domain is indivisible. Okay, so in now, so this is called first normal form. Now you can notice that every relation is in first normal form. Every in the relational algebra, sorry, in the relational model. So I can say in the relational model, what we can say in the relational model, every relation is in 1NF. Every relation is in 1NF. Because in relational model, you know this point, in relational model, domain of every attribute is atomic. Domain of, you already know this, domain of every attribute is atomic. Is atomic. Atomic means elements are indivisible. It means, okay, elements are basically indivisible. Okay, so the domain is atomic. Very simple. Now, what this means? Actually, what this means, when you say domain is atomic, what this means, when you say elements are indivisible, so what this means, you cannot divide the elements. What this means that if your domain has this, for example, if your domain has this, then can you retrieve this? Can you retrieve this? No, you cannot retrieve this. Yes or no? This is what I told you. So what this means, when I say domain is atomic, what this means, it means that if your domain contains this, element, then you cannot retrieve this. Okay, unbreakable. So every element in the domain is a single entity. Every element in the domain is single. You cannot break it. This is the element of the domain. You cannot break it. Like for example, if you want only this, you cannot do that. Okay, so this is the idea. Now, if you can do that, for example, if you can remove this, if you can retrieve this, then what it means? If you can retrieve this, what it means? Your domain is not atomic. Your domain is not atomic. Is this clear? If you can retrieve this, then your domain is not atomic. So this is what is written here. Okay. So you can notice in the relational model, every relation is in 1NF. So this is nothing. This first normal form, this is nothing. Every relation is in 1NF. Okay, now let's start. Now let's start the 2NF, 3NF. Now before that, let me tell you that we will consider, before we study 2NF, 3NF. So first of all, few things let me tell you. This 1NF, this is very trivial. I can say this is very trivial for relational model. This is trivial for relational model. Okay, every relational model is in 1NF. Also, this 1NF is defined with respect to, it is defined with respect to domain. It is defined with respect to domain. If you notice these remaining normal forms like 2NF, 3NF, and BCNF, these are defined with respect to non-trivial functional dependencies. These are defined with respect to non-trivial functional dependencies. Non-trivial functional dependency. Is this clear? Tell me. So these are defined with respect to non-trivial functional dependencies, or I can say these are defined with respect to functional dependencies. Okay, functional dependencies. Now, one more thing that we will consider. So we will consider only non-trivial functional dependencies. So what we will do? So we will consider only non-trivial functional dependencies. We will consider only non-trivial functional dependencies. Only non-trivial functional dependencies with RHS containing only one attribute. With RHS having single attribute. Okay, is that clear? With RHS having single attribute. So these FDs we will create, we will consider non-trivial FDs with RHS containing single attribute. If RHS does not contain single attribute, if RHS does not contain single attribute, then we will split. Then we will split. Alpha goes to A, alpha goes to B. Then we will split. Okay, so this is the idea. So you can see here. So we will consider the domain. We will consider the non-trivial attribute, non-trivial FD with a single attribute on the RHS. Now let's start 2NF. What is second normal form? The definition is very simple. Okay, you know what is prime and non-prime attribute, right? What is a prime attribute? Prime attribute is a member of some candidate key. Prime attribute is a member of some candidate key. Non-prime attribute is member of is not a member of any candidate key. Is not a member of any candidate key. Next, we already know what is full dependency, what is partial dependency. This also we have seen. Now let's start. Let's see the definition of 2NF. What this 2NF says. Let's see the definition. The 2NF definition is actually very simple if you want to understand. Okay, just see the definition. This is a very simple definition. A relation is in 2NF. Basically, 2NF has problem with a particular type of partial dependency. This 2NF has problem. This 2NF has problem with a particular type of partial dependency. Not all partial dependency. It has problem with a particular type of partial dependency. A particular type of partial dependency. Is this clear? So they have problem. Remember, this 2NF has problem with a particular type of partial dependency. Some partial dependencies are allowed. This does not have problem with all partial dependencies. Okay, is this clear? This does not have any problem with all partial dependencies. Does not have problem with all partial dependencies. Does not have problem with all partial dependencies. Okay, only specific. Is this clear? Particular type, specific type of partial dependency is the problem for 2NF. Now, what are these particular type of partial dependency? These partial dependency are these. Basically, candidate key determining non-prime attribute. Is this clear? Candidate key determining non-prime attribute. If this is partial, then relation is not in 2NF. If this is partial, this type of partial dependency is problem with for 2NF. Is this clear? Tell me, is this clear? So this type of partial dependency, if this is partial dependency, then your relation is not in 2NF. So 2NF basically means that this should not happen. 2NF means this should not happen. Okay, this should not happen. So candidate key determining non-prime attribute, this should not be a partial dependency. If you have this type of partial dependency, then not in 2NF. If you have this type of partial dependency, then not in 2NF. Is this clear? Let me know. Anyway, it will be clear. Don't worry. It will be clear. What I'm saying 2NF means what? 2NF should not contain. Everything will be clear. Just wait. Let's see the definition of 2NF. The 2NF definition. A relation is in 2NF. Let's see the definition of 2NF. A relation is in 2NF. If every non-prime attribute is fully dependent on every key. Don't worry, we will take a lot of examples. So many examples we will take that everything will be clear. Just understand the definition. Read the definition carefully. A relation is in 2NF if every non-prime attribute is fully dependent on every candidate key. Okay. See, these words are very important. That every non-prime attribute. These words are very important. This word is important. First of all, every. This is the first word which is important. Every non-prime attribute must be fully dependent on every candidate key. All these words are important. See, read the definition carefully. Every non-prime attribute is fully dependent on every candidate key. Is this clear? So I can also say that a relation is in 2NF if no non-prime attribute is partially dependent on some candidate key. Is this clear? Same definition I can write like this. A relation is in 2NF if no non-prime attribute is partially dependent on some candidate key. Okay, this is another way of writing the same definition. Is this clear? Now, anyway, let's take examples. With example, this concept will become more clear. But let me tell you that for 2NF, what is the problem? For 2NF, what is the problem? The problem is this: candidate key, some candidate key determines non-prime attribute. Okay, this FD, if this is partial, problem if the following FD is partial. Problem is if the following FD is partial. If the following FD is a partial, then that is the problem. If this FD is partial, then that is the problem. Is this clear? If this FD is partial, then that is the problem. Because if this FD is partial, then what is happening? Tell me, if this FD is partial, what is happening? Then non-prime attribute is partially dependent on candidate key. Then non-prime attribute is partially dependent on some candidate key. Okay, don't worry, let's take examples. With the example, this concept will become clear, but this is the definition. Basically, now, wait, Nikhil, Ekta, wait for that. Okay. So now let's see. So a relation is in second normal form if it is in first normal form, but it will always happen. It will always happen in the relational model. In the relational model, this will always happen. So I can say that every non-prime attribute is fully dependent on every candidate key. Okay. So let's start with the example. Let's see this example. Tell me this one. First of all, you find the what are the candidate keys? Let's find out what are the candidate keys. Let's find out. So what are the candidate keys? Also remember, whenever I say only key, if I say this word key, then what I mean? If I say only this word key, then we mean candidate key. If I say only word key, then it means I am talking about candidate key. Okay. If I say the only word key, it means I am talking about candidate key. Anyway, let's see this. So let's find out the candidate keys. So you can notice this is your relation A, B, C, D, E. Now, you can notice C, D, those are not on RHS, correct? Can you notice C, D must be part of every candidate key? C, D not on RHS. C, D not on RHS. Okay, of any FD. So here I can say that C, D must be part of every candidate key. So let's see what C, D can do. C, D can only do this, nothing else. Yes or no? C, D can only do this, can only determine C, D. So now let's check. C, D must be part of every candidate key. Let's check with A. Let's check with A. So what will happen? A, C, D. A will bring B. A can determine B. A can determine B. And this BC can determine E. This BC can determine E. Okay, this BC can determine E. So everything is determined. So I can say that ACD can determine the whole relation. So this is a candidate key. Okay. So this ACD, this is a candidate key. What else? What else? For example, I can say ECD. This is also candidate key. You can check. Okay, you can check. This is also candidate key. The reason, what is the reason? The reason is ED determines A. The reason is ED can determine A. Okay, ED can determine A. Okay, now you can notice BC can determine E. Now you can notice BC can determine E. So BCD can also determine everything. A, B, C, D, E. Okay, so these are the candidate keys. Is this clear? So CDA, CDE, CDB. So these are the candidate keys. Do we have 4 attribute candidate key? Can we have 4 attribute candidate key? Can we have 4 attribute candidate key? No, because remember CD must be part of every candidate key. Now, if you take 2 attributes, then that will be superset of candidate key. If you take 2 attributes, that will be superset of candidate key. So I can say ultimately what are the candidate keys? So in this question, what are the candidate keys? Tell me. So I can say candidate keys. Those are ACD, BCD, ECD. These are the candidate keys. Now let's see. Now what we need to find? We need to find this relation is in 2NF or not. Now we need to check it out. This relation is 2NF or not. So you know the candidate keys. The candidate keys are ACD, BCD, and ECD. These are the candidate keys. And your relation R is this. In this, the functional dependencies are given. The functional dependencies are A determines B, BC determines E, okay, and ED determines A. Is there any non-prime attribute? Is there any non-prime attribute? Do we have any non-prime attribute? No. So there is no non-prime attribute, right? There is no non-prime attribute. There is no non-prime attribute. Because there is no non-prime attribute, so can you create this type of situation? Because there is no non-prime attribute, so you can never create this type of thing. So this type of partial dependency does not exist. This type of partial dependency, some candidate key determining non-prime attribute. Okay, this type of partial dependency does not exist. This type of partial dependency does not exist. Okay, so it is in 2NF. So this relation is in 2NF. So because this does not exist, So this relation is in 2NF because there is no non-prime attribute. Because there is no non-prime attribute, so this type of partial dependency does not exist. Is this clear? This type of partial dependency does not exist. Now let's see the next concept. Next question. Which of the following relation is in second normal form? Second normal form. Let's see the example number 1. The example number 1. So let's see the example number 1, that is R, A, B, C, D. Okay, whatever. Now the FDs are given to you. The FDs are A determining C, B determining A determining D, and AD determining C. First you find what are the prime non-prime attributes. So first you find what are the candidate keys. What are the candidate keys? So you can notice B is not on RHS, right? Yes or no? B is not on RHS. B is not on RHS. So what is B plus? B will determine B will determine A will determine C, and you can notice A will also determine D. So I can say the only candidate key is, so what are the prime attributes? What are the prime attributes? These are non, and these are non-prime. The non-prime are B, C, D. These are the non-prime. Okay, so the only candidate key is B. This is the only candidate key. Now tell me, this type of partial dependency can you create? Can you create? Okay, the only candidate key is B. The only candidate key is B. This is the only candidate key. This is the only candidate key. So tell me, can this be a partial dependency? Like whatever I put here, can this be a partial dependency? Whatever I put here, can this be a partial dependency? This is not a partial dependency. This cannot be a partial dependency. Not a partial dependency. Yes or no? Because this is a single attribute, so can this be a partial dependency? Tell me. We have already seen what is partial dependency. Prime is B. So tell me. Let me know. Can you create this type of partial dependency? We have already seen what is partial dependency. So partial dependency, can you create this type of partial dependency where here you have B and here you have something? So this is not a partial dependency. You cannot create this type of partial dependency. We do not have this type of partial dependency. So this relation is in what? So this relation is in what? This is in 2NF. This is in 2NF. Let's see the next example. In the next example, tell me what will happen. Let's see the question number B. So this we have seen. Let's see the question number B. What about that? So tell me here, what are the candidate keys? First you find what are the candidate keys. So here again you can notice B is not on RHS. Again you can notice B is not on RHS. What is B plus? B plus can only determine B, nothing else. So B plus can determine B. B plus can only determine B. B plus cannot determine anything else. So now tell me, what is the candidate key? Like let's check AB. Let's check AB plus. AB plus is can determine AB. AB can also determine C. Okay, C can determine D. C can determine D. So AB is a candidate key. So I can say what are the candidate keys? So I can say AB is a candidate key. What else? Now you can notice. So this is a candidate key. What else? With B, I can also take C. With B, I can also take C because it will give me CDB. It will give me CDB and CD can determine A. So I can also take CB. What about DB? What about DB? DB is also there. DB is also there, right? So that is also ABCD. So again DB. So can you notice here in this relation, every attribute is prime attribute. In this relation R, every attribute, no non-prime attribute. In this relation R, we do not have any non-prime attribute. There is no non-prime attribute. Because there is no non-prime attribute, so there is no problem. Because there is no non-prime attribute, so there is no problem. So R into NF. So this relation is into NF. Next, let's see the next example. Let's see the next, that is option C. What about option C? So in the option C, what are the candidate keys? Here, just check what is C plus. C plus is C, A, okay, that can determine B, A can determine D. So the only, okay, that is C. So again, the only candidate key is C. The only candidate key is C. The only candidate key is C. So can you create this? So this is into NF. Because can you create this type of partial dependency? Can you create this type? Can this type of dependency be partial? Can this type of partial can this type of dependency be partial? No. So this relation is also in 2NF. This relation is also in 2NF because this type of dependency cannot be partial. Let's see the next option number 4. What about option number 4? Tell me about the option number 4. Here you can notice A, B, C, D. So what are the candidate keys? Find what are the candidate keys. Single attribute candidate key is not there. We don't have single attribute candidate key. Just check AB plus. AB plus will be ABD. And okay, so that will be ABD. Now next, what about the next? Next BD is also there. Next BD is also there. Okay, so BD is also there. Next AC. ACB. Yes, so AC is also there. What else? What about AD? What about AD? What about AD? If you find out AD, that is AD. Nothing else. So this AD is not a candidate key. This AD is not a candidate key. Okay, so we have seen AB, AC, AD. We have seen what is BC. What about BC? BC is not a candidate key. So BC, BD. What about CD? What about CD? C, comma D. That is also not a candidate key. Okay, so these are not candidate keys. So finally, what are the candidate keys? So you can notice AB, BD, AC. So for this relation are the candidate keys. What are the candidate keys? So those are, I can say, the candidate keys. These are basically AB is a candidate key, BD is a candidate key, and AC is a candidate key. Now tell me, can you create a partial dependency? Can you create a partial dependency? First of all, what is non-prime attribute? Again, there is no non-prime attribute. There is no non-prime attribute. Again, there is no non-prime attribute. Because there is no non-prime attribute, so there is no problem. Because there is no non-prime attribute, so there is no problem. So no problem. So into NF. So this is also into NF. Okay, actually, so this is not an interesting question, but let's see more examples. Is this relation into NF? Let's see this. Consider this relation is into NF. First, you write the FDs. Okay, let me take this, give the names. Like, okay, let's call it A, let's call it B, let's call it C. So give some names to the attributes. Give number A, B, C, D, E. Okay, these are your attributes. So tell me what are the FDs? The FDs. You can notice this means AB determining CDE. Yes or no? This means AB determining CDE. AB determining CDE. Correct? Okay, next. So this is AB determining CD and C determining D. And C determines D. So these are your FDs. Now let's check. So AB determines, I am saying AB determines CDE, and you can notice C determines D. So these are your FD. So find what are the candidate keys. Find what are the candidate keys. So candidate keys. So you can notice AB is not anywhere. So if you find out AB is not on RHS. So that will be ABCD. So the only candidate key. So you can notice what are the candidate key, that is AB. So what are the prime attributes? Prime attributes are A, B. What are the non-prime attributes? The non-prime attributes are C, D, E. These are the non-prime attributes. Okay. Now you see. Can you create this type of partial dependency? Do we have this type of partial dependency? Do we have this type of partial dependency? Some candidate key and here non-prime attribute. Here non-prime attribute. This type of partial dependency do we have? This type of partial dependency do we have? This type of partial dependency do we have? Let's check. Let's check. Do we have this type of partial dependency? So what about this? This is the only candidate key. So check AB goes to C. Is this partial? AB determining C. Is this partial? Can you remove something? This is full. This is full FD. What about AB determining D? AB determining D. Can you remove something? This is also full FD. AB determining E. This is also full FD. So can you notice that? Tell me. So there is no such partial dependency. Yes or no? Is there such partial dependency? Do we have such partial dependency? Tell me. Some candidate key, the only candidate key is AB. The only candidate key is AB and non-prime attribute. This type of partial dependency we do not have. Agree? Not in R. So I can say, because you can notice, so this type of partial dependency we do not have. So this R is in 2NF. Is this clear to everyone? Please tell me. So this relation is in 2NF. Okay, let's move on. It will come. Now let's see the next. Let's see this question. Let me create. Okay, so let me create A, B, C, D. And let's assume that B determines D. Let's assume AB determines CD. AB determines CD. B determines C. Let's check it out. Okay, let's check it out. Now tell me, is this relation is in 2NF? Is R in 2NF? First, you find the candidate keys. What are the candidate keys? You can notice AB is not on RHS. This is the only candidate key. Yes or no? This is the only candidate key. Correct? This is the only candidate key. Now you tell me, do we have this type of partial dependency? Do we have this type of partial dependency where here you have candidate key and here you have non-prime attribute? Here you have non-prime attribute. This type of partial dependency do we have? This type of partial dependency do we have? Is there any partial dependency of this form? Yes, you can notice AB determining C. This is partial, yes or no? Can you notice this is partial? This is partial FD. Is this clear? So you can notice this is your candidate key and this is your non-prime attribute and this is your non-prime attribute and this is partial and this is partial. So what I can say? So R is not in 2NF. R is not in 2NF. Is this clear to everyone? Please tell me. So this type of partial dependency we have, where some candidate key is partially determining non-prime attribute. Where some candidate key is partially determining non-prime attribute. Is this clear? AB determining C. Is this partial or not? Nikhil? Is this partial? AB determining C. AB determining C. AB is the candidate key. Is this partial? Yes, this is partial. This is partial because you can remove A. This is partial because you can remove A. This is partial. This is partial because B determines C. This is partial because B determines C. Okay. So this is the idea. So remember, this is partial because B determines C. Now let's move on. So is this clear to everyone? So what is the idea of partial dependency and 2NF? Now let me tell you that this is the definition, as we have already seen. A relation is in 2NF if every non-prime attribute is fully dependent on every key. If every non-prime attribute is fully dependent on every key. Okay. No non-prime attribute is partially dependent on any key. Okay. So this is the idea. Now let's see some more equations. Now before that, let me tell you what is when violation of 2NF will happen. Just tell me when violation of 2NF will happen. When violation of 2NF will happen. When this situation will happen. Violation of 2NF. When this situation, violation of 2NF. Notice. Violation of 2NF will happen when you have this situation. When you have this situation, some candidate key determining some non-prime attribute. Some non-prime attribute. Okay. When this type D is partial. When this, okay, this is not violation, yes or no? This is not violation, but when this is partial, it will be violation. When it is partial, when it is partial, then violation of 2NF. When it is partial, then violation of 2NF, right? Now tell me, when it will be, this whole thing, can I write in one statement? This whole thing, can I write in one statement? This whole thing, when it will be partial? When it will be partial? Tell me, when it will be partial? It will be partial when some subset of it determines non-prime attribute. When it will be partial, when some subset of it determines this. Remember the definition of partial. Remember the definition of partial. Do you remember the definition of partial? For example, what is the definition of partial? I can say x goes to A is partial FD when this is your x, x goes to A is partial if some subset determines A. If some subset, proper subset determines A. Do you remember this definition? So when the, okay, tell me this whole thing I can also write like this. Basically, I can say violation of 2NF will happen when some proper subset of some candidate key. Proper subset of some candidate key determines some non-prime attribute. This is the most easy way of checking whether your relation is in 2NF or not. Some non-prime attribute. Is this clear? Tell me. That's it. If you have this type of FD, this FD is a violation of 2NF. Okay. This FD is violation of 2NF. Is this clear to everyone? Please tell me. So remember, very simple point. I am finding the violation of 2NF. Just apply the definition. This is the definition. Violation of 2NF will happen when some candidate key partially determines some non-prime attribute. Okay. So violation of 2NF will happen. When the violation of 2NF will happen? Violation of 2NF will happen when some candidate key partially determines some non-prime attribute. Okay. So when it partially determines. Okay. So this whole thing, This whole thing is the violation of 2NF. Now, I can also write this in another way. In another way, I can also write this. What is the another way? The another way of writing this word I can remove, and I can say that some subset of candidate key determines some non-prime attribute. So you can notice proper subset of some candidate key determines some non-prime attribute. Is this clear? Proper subset of some candidate key determines some non-prime attribute. So then the violation of 2NF will happen. This is very easy. So what you will do to check for 2NF violation? So how to check 2NF or not? How to check relation is in 2NF or not? Is in 2NF or not? So very simple, the step 1, find all candidate keys. Find all candidate keys. Okay, this is the step 1, find all candidate keys. So from this step, I can also say find prime attributes, non-prime attributes. Find prime comma non-prime attributes. So these prime attributes and non-prime attributes you find. After this, what is the second step? The second step is find, okay, check. What you do, you check if some subset, proper subset of candidate key, if some proper subset of candidate key, if some proper subset of some candidate key can determine some non-prime attribute. Okay, is this clear? Some non-prime attribute. So just do this, very simple. Now let's take example. Consider this example. Is this in 2NF or not? This example you consider. What this example is saying? So can this key is given to you? Already the key is given to you. The question is saying that key is ABC. This is the key. And you can notice B determines F is there. This B determines F is there. Tell me, is this the violation of 2NF? First of all, you tell me, is this partial dependency? My first question, is this partial dependency? Is this partial dependency? And this is not partial, this is full. This is full FD. This is full FD. This is not partial FD. This is not partial FD. This is full FD. Is this clear? Can you remove something from the LHS? This is not partial. Can you remove something from the LHS? Can you remove something from the LHS? But this is violation of 2NF. But this is violation of 2NF. Why? This is violation of 2NF. Why? This is violation of 2NF. Why? This is violation of 2NF. This is violation of 2NF because there is a partial dependency. Because ABC to F is a partial dependency. Because ABC to F, this is partial dependency. This is partial dependency. This is candidate key, and this is non-prime attribute. Is this clear? Tell me, everyone. Tell me. So remember, this is violation of 2NF. This is violation of 2NF because candidate key can partially determine non-prime attribute. This is violation. This is violation because candidate key can partially determine non-prime attribute. Is this clear? Candidate key can partially determine non-prime attribute. That is the reason this is a violation. This is the violation. This is the proper subset of candidate key. This is the proper subset of candidate key. This is a non-prime attribute. So this is the violation. But remember, this is not a, but remember, this is a violation. Yes, this is a violation, but this is not partial dependency. Partial dependency is this. Because of this partial dependency, this violation is happening. Because of this violation, this partial dependency is happening. Is this clear? Tell me, is this point clear? Let's see this example. Consider this one. What are the functional dependencies? First, you write all the functional dependencies. What are all the functional dependencies? You can notice E determines A, correct? E determines A. E determines A. These are the functional dependencies. E determines A. What else? C determines B. C determines B. Okay, so C determines B. What else? AB determine D. AB is determining D. Okay, AB is determining D. Okay, now, so now tell me. First, you find all the candidate keys. What are the candidate keys? So you can notice C, A, B, C. So you can notice CE. Check what are CE. What is CE? So C will be CB. E can determine A. AB can determine D. So this is the candidate key. So how many candidate keys you have? So remember the prime attributes. What are the prime attributes? C, D, E. These are the prime. And what are non-prime? Non-prime. These are basically A, B, D. A, B, D. These are non-prime. Now you tell me. Now let's check. Do we have this type of situation? Do we have this type of situation? Some candidate key determines some non-prime attribute. Do we have this type of situation where this is partial dependency? Do we have this type of situation where this is partial dependency? Do we have this type of situation? Let's check. Let's check. What? Okay, remember CE. So let's check. Can CE determine A? Is this partial? CE determines A. Is this partial? CE determines A. Is this partial? Yes, this is partial, right? So yes, this is partial. Yes, this is partial, right? So that's it. That's it. So this is partial. So this is partial dependency. So what I can say? CE. Candidate key is CE, right? Okay. Is this clear? So this is your partial. Here you can note this is candidate key. You can note this is candidate key, and you can note this is non-prime attribute, and this is the partial dependency. So what I can say? Tell me. So what I can say? Tell me. So this is not into enough. So not into enough. Okay. So not into enough. Tell me, is this clear? This is one way of checking. What is another way of checking? Find the violation. You can notice that this is the violation. C determining B. This is the violation. This is the violation of 2NF. Why? This is the violation of 2NF. Why? Tell me why this is the violation of 2NF. This is violation of 2NF. Why? This is violation because C partially determines B. And you can notice this is non-prime. This is non-prime and this is candidate key. Is this clear? Tell me. So you can notice this is proper subset of candidate key. This is proper subset of candidate key. And you can notice this is non-prime. So this is the violation of 2NF. Is this clear? Anyone has any doubt? Mavit is asking, sir, some proper subset of candidate key can determine non-prime attribute. This dependency can be partial or full. Yes, this can be partial or full. If it is partial, then there is problem. If it is partial, then there is a problem. Is this clear, Mavit? If this is partial, then there is a problem. C determining E, C determining B. Is this full or is this full? This is not trivial. Is this trivial? Is C superset of B? Is C superset of B? So this is not trivial. Vani, this is not trivial. What about this? Is this partial or full? C determining B, this is partial. This is partial FD. This is partial FD. Okay. So is this clear to everyone? Please tell me. Don't confuse between these two. Please understand that. Okay. So don't confuse between these two. What is okay? For what is the violation of 2NF? Both are the violation of 2NF. Remember, what are the violation of 2NF? So violation of 2NF. First, I can say that whenever proper subset of candidate key determines non-prime attribute, this is violation of 2NF. But what is the mistake many students make? They call this they call partial dependency. Okay, remember this functional dependency is violation of 2NF. Is this clear? This functional dependency is, but this may not be partial. Is this clear? This may not be partial. Remember, this may not be partial. This can be anything. This can be anything. This can be partial or this can be full. This can be anything. This is the violation of 2NF. Why this is the violation of 2NF? Because of this will happen, and because of this will happen. Please understand, because of this will happen, because of this will happen. What will happen? Some candidate key partially determines some non-prime attribute. Is this clear? Let me know. So because of this will happen, and because of this will happen. Let me know. So you can use any of them. You can use any of them. But what is the mistake? You can use any of them, but what is the common mistake, misconception? What is the misconception? What is the misconception? The misconception is calling it, remember, is this clear to everyone? Please tell me. Students call it, many students, what they do, they call it partial dependency. They call this partial dependency. This is not partial dependency. Is this clear? So what is the misconception? Misconception in 2NF. What is the misconception in 2NF? The misconception is this, that for example, if I have this A, B, C, D, and let's assume AB determines CD, and let's assume B determines C. Okay. Now in this situation, many students, they say that this is a, you can notice if you find the candidate key, that will be AB. Now many students, what they do this. They say this is partial dependency. This is partial dependency. This is partial dependency. So R not into enough. So R is not into enough. This whole thing is wrong. Is this point clear? This whole thing is wrong. What is the reason? Tell me what is the reason? Because this is not partial dependency. Yes or no? This whole thing is wrong. This whole thing is wrong because this is not partial dependency. This is full. This is full. Yes or no? This is full. You cannot remove anything from the LHS. Can you remove something from LHS? Can you remove something from LHS? No, you cannot remove something from LHS. So this is full. But this is violation of 2NF. But this is violation of 2NF. But this is violation of 2NF. Why? But this is violation of 2NF. Why? Why? What is the reason? This is violation of 2NF because this is partial dependency. Is this clear? So it's like this. So this is a cycle. Are you getting my point? Like this will determine this. So okay, so something like this. But remember, this is a full functional dependency. Anyone has any doubt in this? So remember, both are, if you want to find, you can use this also, you can use this also. You have two things. Now you have two things. Okay, just apply one of them, but understand both of them. Apply one of them, understand both of them. Is this clear? Apply one of them, understand both of them. Okay, let's move on now. Let's see this question. Now tell me, are you getting slowly, are you getting what is 2NF? Now some, okay, or every doubt will clear. Okay, don't worry. Still, if you are in confusion, then don't worry, just wait. Every doubt will clear. Let's see this. Is this in 2NF? Is this in 2NF? So first you find what are the functional dependencies. What are the functional dependencies? C1 determining C2. C1 determining C2. Next. So this is the functional dependency, C1 determining C2. C4 determining C5. C4 determining C5. What about what next? What is the next? What is the next? So C1, C3 determining C2, C4, C5. C1, C3, C1, C3 determining. Remember, this means, okay, remember, please understand, this means LHS. This means LHS and this means RHS. Arrow means RHS. So C1, C3 determining C2, C4, C5. C2, C4, C5. Okay, let's find out. What are the candidate keys? What are the candidate keys? What are those? So you can notice C1. Let's check C1 plus, because C1 is not on RHS. C1 is not on RHS. C3 is also not on RHS. C1, C3, these are not on RHS. So let's check C1, C3. So that will be C1, C3. C1 can determine C2. C1 can determine C2. C1, C3 can determine C2, C4, C5. So this is the candidate key. So you can notice your prime attributes. What are those? C1, C3. These are prime. What are non-prime? What are non-prime? C2, C4, C5. These are non-prime. Is this relation in 2NF? Is this relation in 2NF? This relation, is it in 2NF? This relation. Basically check this. Okay, method 1. What is the method 1? Method 1 is this. Just check, is this, okay, do we have this? C1, C3, this is the candidate key. Basically, method 1 is this. Method 1 is candidate key determining non-prime. Does it happen partially? Does it happen partially? Do we have this? Do we have this? Tell me, do we have this? Yes, there is, because C1, C3 determining C2. This is partial. This is partial FD. Yes or no? This is partial FD where this is candidate key. This is partial FD where this is candidate key. And this is non-prime. And this is a partial FD. So what I can say? So not into enough. So this relation is not into enough. Okay. So this is your method number 1. What is method number 2? What is your method number 2? Method 2, just find this functional dependency. Find this FD. Find this type of FD where proper subset of candidate key. Where proper subset of candidate key determines some non-prime attribute. Determines some non-prime attribute. Okay. Just find this. Find this type of FD. Find this type of FD. Do we have? Yes. Yes, because C1 determines C2. Okay, so we have this type of FD. Find this type of FD. So I can say that this is not into enough. Okay, is this clear? So not into enough. Let me know. Is this clear to everyone? So you have two methods now. Is this clear? You have two methods now to check 2NF. You have two methods. Now let's move on. Let's see this question. Let's change this question for 2NF. Let's quickly do this. I am changing this question for 2NF. Tell me the answer quickly. Let's see option number A. First you check option number A. Tell me what about option number A? A, B, C. This question have we seen? Okay, so anyway, so let's see this. What are the candidate keys? A previous question we saw, is this the same question? Have you written? Is there anyone who has written? See the previous question. See the previous question that we have seen. Is this same as that? Just check it out. Have you written in your notes? Anyone? Please check. Is this question same as that? We have already seen one question where you have four options. This type of question we have seen where you have four options. Is this same as that? Okay, this is different, right? Okay, let's see. So anyway, tell me what are the candidate keys? So you can notice D is not on RHS. A, B, C. D is not on RHS. D cannot do anything. D cannot do anything because D plus will be D. So tell me what will be AD? AD, what is AD? What is AD plus? That will be AD. A can determine C, C can determine B. Okay, so AD is a candidate key. AD is a candidate key. BD will be a candidate key. AD will be a candidate key. And what about CD? What about CD? Yes, CD will be a candidate key. So there is no non-prime attribute. There is no non-prime attribute, right? There is no non-prime attribute. Because there is no non-prime attribute, so there is no problem. Because there is no non-prime attribute, so there is no problem. So this is in 2NF. So this is definitely in 2NF. What about the option number B? What about the option number B? Tell me. What about option number B? So here you have A, B, C, D. So what are the candidate keys? I think this question we have seen. Option number B we have already done. This is also in 2NF. This we have already done. Next, what about option number C? What about option number C? A. I think this is already done. This is also done. This is in 2NF, right? Is this in 2NF? I think this is in 2NF. Okay. What about option number D? What about option number D? Okay, this is also done. Option D, option C. You just check it out. Okay, anyway. So I think this is just a repeated question. Okay, let's move on. Anyway. So this is from, I can say, this is from course paper. And one thing I want to tell you, some misconceptions that many students have. Let me ask you some questions I want to ask. First of all, some questions. In 2NF, can partial dependency be there? In 2NF, we have partial dependency? Can we have partial dependency? Can we have partial dependency? Tell me. In 2NF, can we have partial dependency? Tell me. In second normal form, can we have partial dependency in 2NF? And the answer is yes. Yes, we can have. We can have this type of partial dependency where you are determining prime attribute. For example, consider this example. This is given in code's paper. This is given in the original paper of code. This is already given that 2NF can have this type of partial dependency. 2NF can have this type of partial dependency. So what I'm saying, actually, somewhere I have it. Yes. So you can notice this type of partial dependency you can have. It is okay. This is given in code's paper. You can check. You can check the source is original code paper. It is written in the 2NF section. It is written in the 2NF section. This is written that it is possible for prime attribute to be non-fully dependent on candidate key. Okay, is this clear? Like that is allowed. Is this clear? That is allowed. See what I'm saying. Explain. Okay, let me take this example. Consider this example A, B, C, D, and let's assume AB determines CD, CD determines AB, AB determines CD, CD determines AB, and B determines D. Okay, consider this relation. Is this in 2NF? Is this relation in 2NF? Yes, this is in 2NF because there is no non-prime attribute. So yes or no? So this is in 2NF. So this relation R is in 2NF. This is in 2NF because there is no non-prime attribute. There is no non-prime attribute. So this is in 2NF. Is this clear? We have this in 2NF. But still, consider this dependency. Consider this dependency. AB determining D. Is this partial? AB determining D. Is this partial? Yes, this is partial. Yes, this is partial. So partial dependency is there. Partial dependency is there. But can you notice this partial dependency has no problem to 2NF? Can you notice this partial dependency? This is prime and this is candidate key. So this partial dependency is not a problem to 2NF. Is this clear? This partial dependency is not a problem to 2NF. So for 2NF, this partial dependency is not a problem. Is this clear to everyone? Tell me. So what we have seen. So what are the, okay, remember 2NF. This is a note I want to tell you. Remember, this partial dependency is the problem. Okay, the only partial dependency which is not allowed in 2NF. What is that? Which is not allowed in 2NF. What is that? The only partial dependency which is not allowed in 2NF, that is this, where you have candidate key, some candidate key, where some candidate key partially determines some non-prime attribute. Some non-prime attribute. Is this clear? The only partial dependency, this partial dependency is the problem. Tell me, is this point clear? This partial dependency is the problem. This partial dependency is the problem. So remember this, if this is partial, then there is a problem. Okay, if this is partial, then problem. If partial, problem. If partial, then not true enough. Tell me, is this point clear? But remember, the remaining partial dependencies are not a problem. Is this clear? The remaining type of partial dependencies are not a problem. The remaining type of partial dependencies are not a problem. Are allowed, are not a problem in 2NF. Tell me, is this point clear? Let me know. Next question I want to ask. Consider this question. Some questions back to back, some questions I am asking. Okay, true false statement I am asking. You tell me the answer for all of them. This is, I'm asking true or false. Okay, back to back, and you tell me the answer. The first thing, or maybe R into enough. R is into enough if and only if some non-prime attribute is fully dependent on all keys, all candidate keys. Tell me, is this true or false? Is this true or false? This statement is false. Why? What is the reason this statement is false? A relation is into enough. If what is the reason this statement is false? So this statement is false. What is the reason? The reason is all prime attribute. This must be all. The reason is this must be all. The reason is this must be all. A relation is into enough if all non-prime attribute must be fully dependent on all keys. Is this clear? This must be all. This is the problem. Is this clear to everyone? Please tell me. So this statement is false because this must be all. All prime attribute, all non-prime attribute must be fully dependent on all keys. Is this clear? This is the definition of 2NF. All non-prime attribute must be fully dependent on all keys. Tell me about this one. Now the next statement. I am changing all here. Now tell me, is this true? Is this true? Yes, true. Now this is true. Okay, now let's change. So this is true now. So this is your question number 1. Then you have question number 2. Now let's see the question number 3. In the question number 3, I am changing it to all. I am changing it to some. Now tell me. Now also this is false. Now also this is false. Okay, because what this statement is saying, all non-prime attribute are fully dependent on some candidate key. This is the problem. All candidate keys. It must be fully dependent on all candidate keys. Is this clear? It must be fully dependent on all candidate keys. So all non-prime attribute must be fully dependent on all candidate keys. Is this clear? This is the definition. This is just a definition statement. Nikhil, this is only the definition. I did not even create some creative questions so far. So far, I did not create any creative question. Let's see the next question. So anyway, this is the definition, nothing else. See, this is the definition of 2NF. What is the definition of 2NF? Definition of 2NF says that every non-prime attribute fully dependent on every key. Every non-prime attribute fully dependent on every key. Every non-prime attribute. Okay, this is the statement. Every non-prime attribute fully dependent on every key. Fully dependent on every key. This is the definition. Is this clear? This is the definition we have seen. Now, what is the definition of not into enough? What is the definition of not into enough? So what will be the definition of not into enough? That will be some non-prime attribute partially dependent on some candidate key. Yes or no? Some non-prime attribute partially dependent on some candidate key. This is the definition of not into enough. A relation is not into enough if some non-prime attribute is partially dependent on some candidate key. Is this clear? These are the definitions. Another definition of 2NF, I can say no non-prime attribute is partially dependent on any candidate key. No non-prime attribute is partially dependent on any candidate key. Is this clear? Tell me all these things. Let's see the next. R is in 2NF if and only if all prime attributes are fully dependent on all keys. All prime attributes are fully dependent on all keys. This has nothing to do with 2NF. Yes or no? This has nothing to do with 2NF. This prime attribute, we don't care about prime attribute. We don't care about prime attribute, right? So this statement is false. We don't care about prime attribute. Is this clear? We don't care about prime attribute. We only care about non-prime attribute in 2NF. Is this clear to everyone? What about this one? After this, the next fourth and the fifth. See this. If I change all here and all here, but now I make this change. Here if I make super key. Here if I make super key. Now all non-prime attribute fully dependent on all super keys. Now tell me. All non-prime attribute fully dependent on all super keys. This statement is false. Only candidate keys. Because remember this statement, why this is false? Consider this example. Consider this example A, B, C, D. Okay, where A, let's assume A determines B. Let's assume A determines B. Now here, what are the candidate keys? What are the candidate keys? ACD is the candidate key, right? This is the candidate key. So non-prime attribute is B. So actually what I do, let's assume AB determines CD, C determines D. So here the candidate key, that is AB. AB is the candidate key. Non-prime attribute are C, D. These are the non-prime attribute. Now you can notice that this is a super key. A, B, C determining D. This is a super key. Okay, and this is a partial dependency. Can you notice this is a partial dependency? This is a partial dependency. And this is non-prime. So tell me, is this relation in 2NF? Is this relation in 2NF before that? Is this relation in 2NF? This relation. You can notice that in this relation, A plus is A, B plus is B. So this is in 2NF because we do not have this candidate key partially determining non-prime attribute. Non-prime attribute. This is not there. Okay. Not there. So in 2NF. So this relation is in 2NF. Yes or no? This relation is in 2NF, but you can notice this relation is in 2NF. This relation is in 2NF, but you can notice what is happening. Super key, non-prime attribute, this is partial, but still this is in 2NF. Is this point clear? So every word in the definition is important. Tell me, did you understand? Every word. So this super key also you cannot put here. You cannot put super key here. Every word in the definition is important. This is what I am telling you again and again. All the variations. Again and again, I am telling you that every word is important in this definition. Tell me. So remember, this is the final definition. Ultimately, this is the definition. R into NF if all non-prime attribute fully dependent on all keys. Did you understand 2NF? Please tell me. So remember, in 2NF, this can be possible. Prime attribute, we don't care about prime attribute is partially dependent or not. Tell me, is this point clear? Okay. Now tell me here. What about this one? If a relation has no non-prime attribute, can I say it is in 2NF? If a relation has no non-prime attribute, can I say it is in 2NF? The answer is yes. Okay, what about this one? If there is no composite candidate key. If there is no composite candidate key, means every candidate key has single attribute. If every candidate key has single attribute, then it should be in 2NF. Yes. Why? It should be in 2NF. Why? Because proper subset of candidate key is not there. Because proper subset of candidate key, also you cannot have this type of partial dependency, you cannot have. So the answer is yes. The reason one, what is the reason one? The reason one, proper subset of candidate key, proper subset of candidate key, that will be phi. Proper subset of candidate key will be phi, yes or no? Proper subset of candidate key will be phi. And this phi cannot determine any non-prime attribute. This cannot determine any non-prime attribute. This is the reason one. What is the reason two? Alternative reason. Alternative reason. If every candidate key is a single attribute, then you cannot have this partial dependency. Some candidate key, this partial dependency you cannot have. This partial dependency you cannot have. Not possible. Okay, so this is the idea. Now let's move on. So all these definitions, are they clear? Every definition. So these are the equivalent, all are equivalent definitions. For 2NF, all these definitions are equivalent. A relation is in 2NF if every non-prime attribute is fully dependent on every candidate key. Every non-prime attribute is fully dependent on every candidate key. This is the definition of 2NF. Another definition of 2NF, a relation is in 2NF if there does not exist any FD where proper subset is determining, proper subset of candidate key is determining non-prime attribute. Yes or no? These definitions are equivalent. This is another definition. A relation is in 2NF if there is no functional dependency where proper subset of candidate key is determining non-prime attribute. Okay, so all these definitions, they are basically equivalent. We have already seen. Please tell me, did you get it? This is from course. Did you understand so far whatever we have seen? Let's see this one. Tell me what is the answer for this question. Or maybe I think this is enough for today. Or let's continue. We can finish. We can finish 3 enough. Okay, so tell me what is the answer for this? Tell me the answer for this one. Can a non-prime attribute determine a prime attribute? Can a non-prime attribute determine a prime attribute? The answer is no. It can never. Non-prime attribute can never determine prime attribute. Because if it happens, then it will become prime. Proof by contradiction. What is the proof? The proof you can give by contradiction. Okay, so the proof by contradiction. You can prove by contradiction. So proof by contradiction you can give. What you can say? Let's assume that you have a non-prime attribute. Let's assume A determining B. Assume that this is non-prime. Assume this is non-prime. And assume this is prime. Now what is the problem? Now what will be the problem? Now is there any problem? Yes, there will be problem. See, this is prime. See, B is prime. So what it means? array B is prime. So what it means? What it means? If B is prime, it is part of some candidate key. It is part of some candidate key. So this is candidate key. Correct? This is candidate key. Okay. Now you tell me. Now you tell me. So now, and A is non-prime. What it means? A is non-prime. What it means? It is not part of any candidate key. Is not part of any candidate key. Is not part of any candidate key. Now you tell me what will happen. Now you tell me. Now there is a problem. Now the problem will happen. See, A is determining B. So XA determines XB. So this will become, and this is a candidate key. This is a candidate key. So this will become candidate key. Yes or no? Is this clear? Like basically, this XB is candidate key. So if XA determines XB, then this will become candidate key. Because you can replace this A with B. Yes or no? Is this clear? Sorry, this B you can replace with A. So that is the contradiction. So that is the contradiction. So can a prime attribute? This can never happen. Yes or no? This can never happen. That a non-prime attribute. Here you have a non-prime attribute, and this is determining prime attribute. This thing can never happen. Not possible. This can never happen. Okay, let's see this one. Can a non-prime attribute determine another non-prime attribute? Can a non-prime attribute determine another non-prime attribute? Yes. Yes, it is possible. It is possible. There is no problem. For example, you can take R, A, B, C, D. Let's assume AB determines CD and C determines D. So it is possible. Okay, it is possible. It is possible. What about this one? Can a prime attribute determine another prime attribute? Again, answer is yes. It is also possible. For example, let's assume AB determines CD and A determines C. Consider this. So here you can consider. Okay. So this is also possible. Now let's study 3NF. Third normal form. 3 normal form. Okay, 3NF. Before we start 3NF, anyone has any doubt in 2NF? Please tell me. Before we start the 3NF, do you have any doubt in the 2NF? I am giving you conclusion of 2NF. 2NF conclusion. This conclusion, only the important points I am telling you. What are the important points in this 2NF? The first important point is, if you have this, then not 2NF. Okay, if you have this, let's assume proper subset of candidate key, proper subset of some candidate key. If that determines proper subset of some candidate key, that determines some non-prime attribute. Some non-prime attribute. This is the violation. Okay, this is the violation of 2NF. Remember, this is the violation of 2NF. So this implies not 2NF. And not 2NF implies this. This implies not 2NF, and not 2NF implies this. Okay. So this is your 2NF conclusion I am telling you. What else is 2NF conclusion? 2NF conclusion is this. Some candidate key. This is another definition. Another definition is some candidate key partially determines some non-prime attribute. Then that is not 2NF. This is also not 2NF. So these are two alternative definitions. Is this clear? This is the 2NF conclusion. Okay. Now let's see this. So third normal form, 3NF. Now in this 3NF, what will happen? In this 3NF, remember in 2NF we are saying this. If you notice, a relation R in 2NF, this we already know. A relation R is in 2NF. What we are saying? A relation R is in 2NF if every non-prime attribute or I can say some non-prime attribute. If no non-prime attribute is partially dependent on any candidate key. Yes or no? This is what we say, correct? Okay. Anyway, now the same definition for 3NF. If I go for 3NF, then this partial will be replaced by transitive. That's it. This is the only change. This is the only change. Is this clear? A relation is in 3NF if no non-prime attribute is transitive dependent on any key. No non-prime attributes transitive dependent on any key. Or I can say that every non-prime attribute, what should happen? What should happen with every non-prime attribute? Every non-prime attribute is non-transitive dependent. Is non-transitively dependent. Is non-transitively dependent on every key. On every candidate key. This is the definition of 3NF. Basically, the problem in 3NF, the violation of 3NF, when it will happen? The violation of 3NF, when it will happen? It will happen in this situation. It will happen in this situation that some candidate key transitively determine. Some candidate key transitively determine some non-prime attribute. Some non-prime attribute. In this situation, the violation will happen. Okay. In this situation, some candidate key transitively determines some non-prime attribute. In this situation, violation will happen. But this is not easy to check. Can you notice? Can you notice this is not easy to check? It will take a lot of time. If you check like this, yes or no? If you check like this, it will take a lot of time. So this definition, remember, in the GATE exam, there are many questions. I will take all those questions. In GATE exam, there are many questions on this definition. So while solving the question, you don't need to apply this definition. When you are solving a question, you don't need to apply this definition because this definition will take a lot of time. We will see equivalent definition. For 2NF, we have seen equivalent definition. Yes or no? For 2NF, we have seen two equivalent definitions. Equivalent definitions we have seen. Similarly, for 3NF, we will see equivalent definitions. One of them is very easy. One of them. But all these definitions, in the GATE exam already, there are many questions. 5 or 6 questions are there in the GATE exam where this statement is given as a true-false statement. So this is the violation of 3NF. Violation of 3NF means some candidate key transitively determining some non-prime attribute. Okay. Now, few things I want to ask you. Very simple point. Let me tell you that when violation of 3NF will happen, it is very easy. When violation of 3NF will happen, it is actually very easy. You can notice, just tell me, violation of 3NF will happen when? In this situation, when you have this FD, for example, not a super key. Here, not a super key. If something is not a super key, can it be a candidate key? If something is not a super key, can it be a candidate key? No. So this is the violation. Remember, violation of 3NF will happen when not a super key implies so what I'm saying, this violation will happen when not a super key implies non-prime attribute. This is the violation. That's it. It is very easy to check, yes or no. This is quite easy to check. Not a super key implies non-prime attribute. This functional dependency is violation of 2NF. Why? Tell me why this is like, what it has to do with transitive? What this has to do with transitive? Very simple. Let's assume you have a, okay, why? This is a simple question. Why this is violation of 3NF? Like, what is transitive here? Remember, this is the definition. Some candidate key transitively determining some prime attribute. Some candidate key transitively determines some non-prime attribute. So this is the definition. This is the definition. Now, I am saying that this is what I am saying. I am saying that this is violation. Not a super key implies non-prime attribute. This is violation. Why? So let me give you the proof. Because if this happens, then this will happen. The proof idea. What is the proof idea? The proof idea is this. If this happens, not super key determines non-prime attribute. If this happens, then this will happen. What will happen? If this happens, then this will happen. And if this happens, then this will happen. So basically what I'm saying, then this will happen, that some candidate key transitively determining some non-prime attribute. Okay, are you getting my point? Again, these two things are same basically. If this happens, then this will happen. If this happens, then this will happen. How can I prove it? This is very easy to prove. See, if you have this type of situation, let's assume that this alpha is not a super key. Let's assume. Okay, and let's assume this A is a non-prime attribute. This is a non-prime attribute. Okay, this is a non-prime attribute. Now tell me one thing. Can alpha determine some candidate key? This is my first question. Can alpha determine some candidate key? Can alpha determine some candidate key? Why no? The answer is no. Why? Because if alpha is determining some candidate key, then this will become super key. Because if alpha determines some candidate key, then alpha becomes super key. So alpha cannot determine candidate key. Agree? Okay, yes or no? Now very simple. Now if you have this, okay, if you have this functional dependency, if alpha goes to A, then what will happen? If this is there, then what will happen? If this FD you have, where not a super key implies non-prime attribute, then what I can say? Then what transitive dependency I can create? Then I can create this transitive dependency. You take a candidate key, implies alpha, implies A. Alpha cannot imply CK, yes or no? Alpha cannot imply CK. So now I can say that this is the problem of 2NF. Is this proof clear? Tell me. Did you understand this proof? Very simple. If you have this type of situation, see, if you have this type of situation where not a super key, if you have this type of situation where not a super key implies non-prime attribute, then you can create this type of transitive dependency. If this happens, then you can create this type of transitive dependency. Is this clear? This is your transitive dependency. This is your transitive dependency, CK to A. Yes or no? Is this clear? This is your transitive dependency. Let me know, did you get it? Anyone has any doubt? Okay, let me ask you a few questions. Just tell me this question. Some simple questions I am asking you one by one. Okay, you tell me. You can notice that this non-prime attribute, let's assume non-prime attribute A determining non-prime attribute B. Is this a problem to 2NF, 3NF? Is this a problem to 3NF? Is this a problem to 3NF? Is a problem to 3NF? Can you prove it? Take copy pen. Nikhil, Yuvraj, Ekta, all of you, take copy pen. Can you prove it? Why this is a problem to 3NF? Non-prime attribute determining another non-prime attribute. Is this a problem to 3NF? Yes, this is a problem. You can notice this is a problem. The answer is yes. The answer is yes. The reason one, I can give you many reasons. For this, I can give you many reasons. But what is the reason number one? The reason number one is very simple. This is not a super key. I just see. This is not a super key. Reason number one is very simple. Reason number one is very simple. This is not a super key, right? Yes or no? Reason number one, very simple. This is not a super key. Because non-prime attribute can never be a super key. Correct? Not a super key implying non-prime attribute. Not a super key implying non-prime attribute. This is the problem. And this is the problem. Yes or no? Tell me, did you get it or not? Not a super key implies non-prime attribute. This is a problem. What is the another reason? What is the reason number two? Can you give me transitive dependency? Can you give me transitive dependency? There is transitive dependency where candidate key is going to non-prime attribute. Can you give me this type of transitive dependency? My question is, can you give me this type of transitive dependency? Yes, you can give, very easy, because if you have non-prime A to non-prime B, if you have non-prime A to non-prime B, then what I can say, I can very easily give a transitive dependency where basically take the candidate key, that every candidate key can determine A is determining B. Because this is non-prime attribute, so it cannot determine CK. Because this is non-prime attribute, so it cannot determine CK. Picture perfect. Yes or no? Picture perfect. So here what if? So here who is transitive? Tell me. So here I can say candidate key, and this is non-prime B, and this is transitive dependency. Okay. So this is the transitive dependency. Are you understanding these things? See, at the last, you can by heart also. All these things you can by heart also. Like in the 2NF, I gave you the conclusion, right? In the 2NF, I gave you the conclusion, the last two slides. In the 2NF, the last two slides, you can by heart them also. But if you understand, then you can handle any type of question. Whatever question they can create, you can handle. Tell me, did you understand? Like, are you understanding these things? See, everything I'm giving the proof. For everything I'm giving the proof. like non-prime attribute to non-prime attribute. This is a problem. But why this is a problem? Many students, they by heart it. Many students, okay, what they will do, like for example, many what happens, like the teacher will write few things, okay, 4 or 5 things he will write, and the students will by heart, okay, this is a problem, non-prime to non-prime problem, this to this problem, this to this problem, okay, so these are the problem. So like this, students will by heart. And when you by heart, then many good questions can be created in the GATE exam. We will see already there are good questions in the GATE exam. There are 5 or 6 good quality questions. Okay, so we will see those questions. So don't by heart. Are you understanding everything? Tell me. Like this non-prime attribute to non-prime attribute. Why this is problem to 3NF? Why this is a problem to 3NF? Because there is a transitive dependency from candidate key to non-prime attribute. Yes or no? When you have non-prime to non-prime, then very simple. They see non-prime to non-prime. Why this is a problem? Why this is a problem to 3NF? Because there is a transitive dependency from candidate key to non-prime. Okay, is this clear? Anyway, now tell me. So this was question number 1. Now let me ask you question number 2. Is this a problem to 3NF? Is this a problem to 3NF? Is this a problem to 3NF? This is never possible. This is never even possible. This is never even possible. This is never possible. This FD is never possible. Okay, let's see the question number 3. Prime plus non-prime attribute. This combination. Let's assume you have a prime plus non-prime attribute. This is combination, which is not a super key. Make sure it is not a super key. Make sure it is not a super key. Make sure it is not a super key. Determining non-prime. Is there any problem? Determining non-prime. Is there any problem? Is there any problem in 2NF? 3NF. Is there any problem in 3NF? The answer is yes. Yes, this is the problem in 3. Okay, this is not allowed. This is what I'm saying. Yes, this is a problem. Is this a problem in 3NF? Yes, this is a problem. And the same logic. Can you notice the same logic will work? The same logic will work. For example, let's you can call it, for example, let's assume you can call it alpha. The same logic will work. This alpha goes to beta, where this is not a super key. Where this is not a super key. And this is your non-prime attribute. So the same logic will work. Why this is a problem? Not a super key implies non-prime. This is a problem. This is a problem in 3NF. Correct? And why? Why? Because you can create a transitive dependency. Because you can create a transitive dependency. Alpha is not a super key. So because you can create a transitive dependency. So this transitive dependency you can create from, okay, you can create this transitive dependency you can create where here you have non-prime. So this is also a problem. Is this clear? Let me know. Okay, so basically anything of this format is a problem. Remember, like this is also a problem. Like remember, anything of this format. Let me explain. Now let me give you the summary. Let's see the summary now. So first of all, let me give you the summary. This is quite easy. This 3NF. So 3NF summary. What is the definition? Tell me. Let's see the definition. First of all, what is the definition? What is the definition? The definition is very simple, that a relation is in 3NF if every non-prime attribute, tell me, if every non-prime attribute, what should I write? If every non-prime attribute is non-transitively dependent, on every key, on every candidate key. Is this clear? Tell me, yes or no? Non-transitively dependent. Every non-prime attribute is non-transitively dependent on every candidate key. Okay, these words are very important. Every non-prime attribute is non-transitively dependent on every candidate key. I can also say that no non-prime attribute is transitively dependent on any candidate key. I can also say this. Yes or no? I can also say this. What is the another definition? The another definition is this. Another definition. Definition number 3. So definition number 1, definition number 2, definition number 3. What is the definition number 3? Relation R in 3NF. Relation R in 3NF if no functional dependency, no FD of the following form. No FD of the following form. Like this type of FD should not be there. Which type of FD? Tell me. No FD of the following form. You should not have any FD of the following form. Which form? Tell me which form. No FD of the following form, where non-super key determines non-prime attribute. Okay, is this clear? So this, okay, so no FD should be like this. Just understand this, that's it. You don't have to remember all those different things. Is this clear? Ekta, Yuvraj, Mavit, tell me, is this clear? Just this one thing is enough. Non-super key determining non-prime attribute. This is enough. This same thing you can write in many different ways. So what are the 3NF violations? What are the 3NF violations? What are the 3NF violations? In one word, if you want to write, then this is the violation. This is the violation if you want to write in one word. Not a super key determines non-prime attribute. Okay, so this is the problem. If you want to write the same thing in different ways, then you can write like this. Non-prime to non-prime is a problem. Okay, non-prime to another non-prime, this is a problem. And why this is a problem, you already know. Yes or no? Why this is a problem, you already know. Because this is not a super key. Not a super key implies non-prime. So this is a problem. Next you can notice proper subset of candidate key determining non-prime. Why this is a problem? Because this is not a super key. Proper subset of candidate key cannot be a super key. Yes or no? A proper subset of candidate key, this is not a super key. This is a problem in 2NF also. So problem of 3NF, is also, so remember, problem of 2NF is also problem of 3NF. Also, you can say, for example, maybe prime plus non-prime, prime plus non-prime, determining non-prime, prime plus non-prime, determining non-prime. Must, okay, it must be not super key, must be non-super key, must not be super key, must not be super key. Okay, so these are some ideas. Okay, so these are some 3NF violations. Can you notice in all these violations, RHS has non-prime attribute. In all these violations, RHS has non-prime attribute. RHS has non-prime attribute in all these violations. So basically, remember, we don't care about the prime attributes. The prime attribute may or may not be transitively dependent on candidate keys. Let's see some examples. With example, this concept will become more clear. Let's see some examples. Mavit is asking, can we say combination of non-prime and prime? Non-prime attribute is non-prime attribute. Its combination of non-prime attribute cannot determine prime attribute. Mavit, combination of non-prime attribute cannot determine prime attribute, but combination of non-prime attribute can determine non-prime attribute. Okay, like combination of non, here it can happen. Here you can have non-primes. Okay, here you can have non-primes. You can have multiple non-primes also, no problem. Okay, next. So now let's see this question. Tell me which is in 3NF. Which is in third normal form. Let's check it out. Let's see the first one. Tell me about the first one. Is this in 3NF? So first you find what are the candidate keys. What are the candidate keys? Here, A to B. We have already done this. Please check your copy. Please check your copy. What is the candidate key here? So you can notice B. B, A, C, D. Yes. So that is B. So now tell me, this is your candidate key. Okay. So definitely this is in 2NF. Definitely this is in 2NF. Yes or no? Definitely this is in 2NF because you have this single attribute candidate key. Because it is simple candidate key. Because it is simple candidate key, so this is in 2NF. What about 3NF? What about 3NF? Tell me what about 3NF? Look at this. This is the violation of 3NF. Yes or no? This is the violation of 3NF. Look at this. Look at this. Violation of 3NF. Violation of 3NF. Why? What is the reason this is violation of 3NF? Because non-prime. Determining non-prime. So this is violation of 3NF. So this relation is not in 3NF. Okay, this relation not in 3NF. The same question, how will you solve using transitive dependency? The same question, how will you solve using transitive dependency? Where is transitive dependency? Do we have this type of transitive dependency? Do we have this type of transitive dependency? Tell me. Can you give me this type of transitive dependency? Yes, there is this type of transitive dependency. This is method number 2. This is method number 2. Can you give me this type of transitive dependency? Yes. So basically B determining C. This is transitive, right? B determining C, that is transitive. Agree or not? B determines C, that is transitive. This is a candidate key. This is non-prime. So this is so not 3NF. So your relation is not in 3NF. Okay, your relation is not in 3NF because you can notice B can determine A can determine C, A cannot determine B. Picture perfect. The diagram. So this is transitive dependency. So who is transitive? B determining C. This is transitive. Is this point clear? Tell me. Alternative method. Alternative method. This is alternative method. So you can also check transitively. So you can either check like this. Either you can check like this, or you can check like this. Both of them, did you understand? Did you understand both of them? Either you can check like this, non-prime to non-prime. This is the violation of 3NF. This is a violation of 3NF. Or you can check like this. This candidate key to non-prime. This is a transitive dependency. So you can check like this. Okay, let's see the next question. Tell me about the B, option B. What about option B? So what are the candidate keys for option B? For option B, what are the candidate keys? So I think AB is the candidate key. AB is the candidate key. BD is the candidate key. BC is the candidate key. So these are the candidate keys. So there is no non-prime attribute, right? There is no non-prime attribute. So can we have any problem? There is no non-prime attribute. There is no non-prime attribute. So no problem. So 3NF. So 3NF. So there is no violation. So this is 3NF. Okay. Next. What about the next? Option C. What about option C? What is the candidate key? A, B, C. C, A. So the candidate key is C, right? The candidate key is C. This is the candidate key. So now tell me. So because of this, this is in 2NF. So R is in 2NF. Now tell me about that 3NF. What about 3NF? Can you notice this is the violation? In front of you, you have the violation. This is the violation of 3NF. This is the violation of 3NF. Okay. This is the violation of 3NF. So 3NF is much easier actually. Yes. This is violation of 3NF. Why? Because non-prime determines non-prime. Non-prime determines non-prime. So that is the violation of 3NF. Okay, this is your, so I can say this R is not in 3NF. Not in 3NF. Can you check this same? Is there any transitive dependency? Yes, this is the transitive dependency. Like for example, what I can do, I can say C determining B. This is transitive dependency. Agree or not? This is transitive. This is transitive dependency where this is the candidate key, this is the non-prime attribute, and this is the candidate. So this is a picture perfect. Again, you will get the picture perfect. So this is your method number 2. You can check like this also. What about the next? What about the next? What about D? What is candidate key? For option D, what is candidate key? A, B, C, D. Okay, so there is no non-prime attribute. If you check what are the candidate keys, in this, the candidate keys will be like this. I think BD will be the candidate key. You can check it out. BD, AB, AC. BD, AB, AC. No non-prime attribute. There is no non-prime attribute. So 3NF. So this is in 3NF. There is no problem. So this is in 3NF. Okay, like this. Now, so did you understand 3NF? Checking 3NF. Did you understand? Please tell me. Did you understand how to check 3NF or not? If a relation is in 3NF or not, how to check that? Okay. So now let's take a small break. After the break, we will continue and we will study BCNF. Then we will solve those nice 5 gate questions. I told you there are 5 gate questions, very nice gate questions on these true false statement. I told you, yes or no? There are 5 gate questions which are true false statements. And let me tell you that if you understand the correct concept, then only you can solve them. You will be surprised what will happen. See, many students, they have misconceptions. Basically, they study wrong concepts. Okay, from some coaching institute, they will study some wrong concept, and then it is very surprising. I will give you this paradox. I will give you that it is very surprising that they are getting the correct answer. It is very surprising, because I will give you the paradox. I will give you the paradox that for one question, your logic does not apply on the another question. For this question, your logic does not apply on this question. So there is a paradox, right? And this paradox is because your misconception. Yes or no? This paradox happens because there is wrong understanding, or I can say misconception. If you understand the concepts in a right way, then this type of paradox will not happen. So anyway, after the break, we will study BCNF, and also we will solve those 5 questions. Those 5 gate questions we will solve, and I will prove it to you that that so many students, they study wrong concepts, and gate exam is asking a very good questions. Already 5 questions have come. Like, it's not like these questions will come. It's not like sir Deepak sir is teaching a high level, it is not required for gate exam. I will tell you, those 5 questions are based on what we have seen. Everything that we have seen, those 5 questions are based on these concepts. Okay, like concept of partial dependency, correct definition of partial dependency, correct definition of transitive dependency, correct definition of 2NF, correct definition of 3NF. You must understand, then you can solve those 5 questions. Okay, so let's take a break. After the break, we will continue. So let's take a break till 12. Okay, we will start at 12. Okay, let's finish it today, so that we can finish DBMS as early as possible. If we can finish DBMS as soon as possible, then we can start our practice course. Okay, basically we can start computer organization, and computer organization will be recorded. Okay, so computer organization will be recorded, so I will start the practice course also in parallel. Is that clear? So the practice course we will start in parallel. Okay, computer organization will be recorded, so don't worry about that. Okay, every day you will get one lecture, 1 or 2 hour lecture you will get every day. Nikhil, you are a goclasses student. In goclasses, every concept, every subject, once you study that subject in the goclasses, I think you will never fear that subject. I think, like we have seen TOC, theory of computation, decidability, undecidability. Okay, in operating system, synchronization, multi-level paging. So all the concept that we have seen, sequencer circuit, everything. So once you understand the concept, these things will become very easy. Once you understand every concept. Similarly, computer organization also. Once you understand all the concepts in a correct way, then it will become very easy. Okay. Okay. Thank you. So see you at 12. We will start at 12.